Hello students, welcome to the sessions of lectures of Mathematics 1. Up to last session, we have discussed three different cases of the Frobenius method, and in today's session, we are going to discuss the case 4 where roots are differing by an integer and sum of the root coefficient is going to become infinite for the smaller root r is equal to r1. In case 3, it is going to be indeterminate and here it is going to be infinite. Okay. Whenever it is going to be infinite, in that case, you have to modify your a0 by b0 into r minus r1. Okay. Now, here I have written a in a form of a0 because see your answer will going to be in a form of a0 and a0 will be replaced with b0 into r minus r1. Okay, that's why I have written it in this form, and whatever the answer you get into whatever AMs, all AMs are written in this form. It is not exactly in this form. Here I have written in this form, but it is not right like that. Okay, so basically it is, if you are going to write, then you have to put the values AM, and in AM you have to put A0 by replaced by B0 into R in minus R1. Okay. Now, starting with an example, the same thing you have to repeat. Again, here it is given that using Frobenius method. So, if you are starting with a solution, then you have to write down your equation in the form of px plus qx. So, it is x square minus 1 upon x square y is equal to 0. So, your p of x is 1 upon x, q of x is x square minus 1 upon x square, and px and qx are not analytic at x equal to 0. So x is equal to 0 is a is a singular point, and it is singular point. So first of all you have to find two limits, x tends to 0, x into px, that will be a limit x tends to 0, x into 1 upon x, that will be a 1, and same manner limit x tends to 0, x square into qx, that will be a limit x tends to 0, x square into x square minus 1 upon x square. So x square cut out and you will get answer minus 1. And therefore x is equal to 0 is a regular singular point. It is a regular singular point. Correct? Now, starting with a standard assumption, assume y is equal to sigma m running from 0 to infinity am x raised to m plus r. I am now writing in the direct form, be a trial solution, or write it in a simple form, that is x raised to r into, and that will give you y is equal to sigma m running from 0 to infinity am x raised to m plus r, and y dash is sigma m running from 0 to infinity m plus r am x raised to m plus r minus 1, and y double dash, that will be a m running from 0 to infinity m plus r minus 1 am x raised to m plus r minus 2. Now putting values of y dash, y double dash in equation 1. Now, what is your equation 1? X square y double dash plus x y dash plus x square minus 1 of y is equal to 0. Okay. Now see, you will have, I am going to multiply x square directly inside and we are going to separate the terms. That will give you sigma m running from 0 to infinity m plus r minus 1 am x raised to m plus r plus sigma m running from 0 to infinity m plus r am x raised to m plus r plus x square into y. So that will be a sigma m running from 0 to infinity am x raised to m plus r plus 2 minus sigma m running from 0 to infinity am x raised to m plus r is equal to 0. Correct? Now these three terms are same as they have am x raised to r plus m plus r. So common out it, and that will give you sigma m running from 0 to infinity m plus r, m plus r minus 1 plus m plus r minus 1 into am x raised to m plus r. Correct? And this term plus sigma m running from 0 to infinity am x raised to m plus r plus 2 is equal to 0. Now see, here we have to simplify. So again I am writing it in a form of z. So z into z minus 1 plus z minus 1. So that will going to be a z square minus z plus z minus 1. So these two will be cancelled out. And z square minus 1 has a factor z minus 1, z plus 1. Correct? So we are going to write it in a form of sigma m running from 0 to infinity m plus r plus 1 m plus r minus 1 am x raised to m plus r plus sigma m running from 0 to infinity am x raised to m plus r plus 2. Now see, you have to reduce this power in a form of m plus r. So you have to replace m by m minus 2. So the first term remains as it is, m running from 0 to infinity m plus r plus 1 m plus r minus 1 am x raised to m plus r. Here it is going to be a m running from 2 to infinity a of m minus 2 x raised to m plus r. Done. So separate the terms with 0 and 1. So if you are going to put m 0, then you will have r plus 1 r minus 1 a 0 x raised to r plus r plus 2 into r into a1 x raised to r plus 1, and from 2 combine both the summations, and that will give you m plus r plus 1 m plus r minus 1 into am plus a of m minus 2 into x raised to m plus r is equal to 0. Okay. Now what we are going to do is, we are going to compare the coefficients with 0. So comparing the coefficients with 0, that will give you comparing coefficients with 0, that will give you first we are going to compare the coefficient of x raised to r, that is r plus 1 r minus 1 a0 is equal to 0, but a0 is not equal to 0, so you will have r is equal to minus 1 and 1. So r1 is minus 1, r2 is 1, and that implies r2 minus r1, that is 1 plus 1 is 2, that means it is integer. Now for x raised to r plus 1, you will have r plus 2 into r a1 is equal to 0. So if you are going to put r is equal to minus 1, then you will have minus a1 is equal to 0. That means a1 is equal to 0. And if you are going to put r is equal to 1, then you will have 3 into 1. So again a1 is going to be 0 in both the cases. Okay. Now we are going on to the general term, x raised to m plus r. That is m plus r plus 1, m plus r minus 1, am plus a of m minus 2 is equal to 0, plus a of m minus 2 is equal to 0. Correct? So am is minus of am minus 2 divided by m plus r plus 1, m plus r minus 1. Now m is running with 2, so m is equal to 2, and that will give you a2 is equal to minus a0 divided by r plus 3, r plus 1. Correct? Same manner, m is equal to 3, then you will get a3 is equal to minus a1 divided by r plus 4, r plus 2. But a1 has a value 0, so a3 is 0, same manner a5 is going to be 0. So m is equal to 4, and that will give you a4 is equal to minus a2 divided by 4 plus 1, that is 5. So r plus 5 and r plus 3. But a2 has a value a0 upon, so you will have a0 upon r plus 5, r plus 3, again r plus 3 and r plus 1. Correct? So if you are going to put m is equal to 5, then a5 is going to be a 0, because you will get minus a3 and a3 is equal to 0. So putting values of m in equation 2. So that will give y is equal to x raised to r, a0 plus a1x plus a2x square, a3x cube, and so on. So that is nothing but x raised to, okay, we are going to write it on next page. Y is equal to x raised to r, a0, a1 has a value 0, a2 has a value a0 upon, a2 has a value a0 upon r plus 3, r plus 1, x square, a3 has a value 0, a4 has a value a0 upon r plus 5, r plus 3 whole square, r plus 1 into x raised to 4, and so on. So if you are going to common out a0, then we will have 1 minus x square upon r plus 3, r plus 1, x raised to 4 upon r plus 5, r plus 3 whole square, r plus 1 minus whatever dot dot dot. Now see, if you are going to put r is equal to minus 1, because first you have to put minus 1, then in that case this denominator is going to be 0. Also this denominator is going to be a 0. That means in each denominator you have a factor r plus 1. So this becomes infinite. So this is a case 4. Now here your case is decided. So for r1 is equal to minus 1, we have infinite coefficient, and that implies replace a0 by b0 into r minus r1, that is b0 into r minus minus plus 1, and therefore your equation is going to be b0 into x raised to r plus 1 I am going to multiply inside, so that will give you r plus 1 minus x square upon r plus 3 plus x raised to 4 upon r plus 5 r plus 3 whole square, and so on. I am going to say this is equation 3. So y1 is simply obtained by putting y is equal to r is equal to minus 1. That means it is b0 x raised to minus 1 minus x square by 2 plus x raised to 4 by 4 into 2 square plus dot dot dot. But for second solution, you have to differentiate this term with respect to r. So for second solution, y2. Okay, I am going to write here y first because it is b0 x raised to r plus 1 x square upon r plus 3 x raised to 4 upon r plus 3 whole square into r plus 5. So if you are differentiating with respect to r, then you have to apply product rule. In first, b0 x raised to r has a derivative x raised to r into log x. This bracket remains as it is. And plus b0 x raised to r as it is, and you have to differentiate these terms with respect to r. So r has a derivative 1. 1 upon has a derivative minus 1 upon x square, so 1 upon r plus 3 the whole square. Here I am going to write this in the form of r plus 3 raised to minus 2. So as a derivative minus 2 upon r plus 3 whole cube r plus 5 minus 1 upon r plus 3 whole square r plus 5 whole square into x raised to 4. And here y2 is given by del y by del r at r is equal to minus 1. So here it is going to be a y1 into log x plus the second term is going to be a b0 x raised to minus 1 1 plus x square upon 2 square plus, see, simplifying this term, that will give you something minus 5 by 64 x raised to 4 and so on. And therefore the general solution is y is equal to c1 y1 plus c2 y2. Okay, so here the differentiation part is the typical one, and you have to remember that you have to find out the derivative with respect to r, not with respect to x. Okay, so these are the topics which we have covered in today's session. If you have any doubt or any query regarding this topic, then please feel free to contact me. Thank you so much.